So let's call
So
this
there's a
project.
question whether if we should sign in with our emails.
Yes, you need to sign in with your HSE email. So after you have created the project called webinar, you right click on it like this. And then you see what? Close project and new. All right. We are coming to select schematic. Okay. So the first thing we do is to capture the schematic. After that, then we can make the board from it. Okay. Now, I heavily encourage you to also start doing yours whilst I'm also doing it so that we can be on the same page. Or you can come and watch the video later on and follow it if you cannot follow me whilst I am doing it. Now, so this is your a minute. Now, can you all see the schematic interface? Okay. Can you all see my other screen, the new screen?
Yes.
All right. So this is the screen for capturing your schematic. Let me just take you around the interface and show you some of the controls. This one here is for moving things, for moving one component from one place to the other. You can use this one to mirror components. If it is facing you and you mirror it, it will face the other direction. You can use this one to rotate a component. And then you can use this one to copy a component, and you can use this one to paste it. You can use this one to delete a component, and you can use this one to change a component from one to the other. You can use this one to add a new design block, and you can use this to add a new part. This one is the most important control that you are going to be using in your schematic. I'll continue with the rest when we need to use them.
Sorry, sir, someone is complaining they can see your pointer and where you were pointing to.
I am pointing to the left of my screen. Can you see it now?
Ajua, can you please confirm that?
Daniel, can you see it?
Yes, Ajua, she said yes, she can see now.
All right. So we'll be using this one, the name and the value as well a lot. You can use this one to change the name of a value, a component, and you can use this to change the value of the component. All right. So let's get to work. The first thing I'll add is I need to add a title block to my project. The title block makes your document a technical document. So you click on add. When you click on add, the library takes a while to load. Okay. So you have another screen looking something like this. Can you see the screen?
Yes, please.
All right. So you can go down. You have a lot of library paths over here. Now, there are three ways that these library paths are stored in Eagle. One, they can either use the name of the manufacturer to name the library. So, for example, if you are looking for something from Texas Instruments, all you have to do is to look for the name Texas. If, for example, you are looking for voltage regulator, you can just use the name voltage regulator. So you scroll down till you see voltage regulator. Is that clear? Another thing they can use is they just use the name of the component directly, like the way, let's say 12 volt module. Okay. So let's say we are looking for title block. The title block is under a library path called frame. So I'm going to scroll down all the way till I see a library path named what? Frame. So under frame, I'm going to choose one of them, but I prefer this one. A4L/lock. The L stands for what? Landscape. So I'm going to choose something like this, and then I'll place it on this plus. Do you see this plus over here? this plus is the origin of the document. So I'll place the corner of the frame on the plus. And then I'll still have it at the end of my cursor. All I have to do is to press on escape. Now, if you can't see everything well, all you have to do is to click on this icon over here called zoom to fit. So this is what I have done. Now, at this point, you need to save your diagram. So you can click on save, and then you give it a name, webinar, and then you save it. Any questions?
And please, which frame did you choose again?
I chose A4L hyphen lock. Have you seen it?
Yes, thank you.
I think I'm going too fast. Should I slow down?
Yeah, a little bit. Please slow down, please.
Sorry. All right, can I move on now? Okay, so the next thing, which is the most important thing in the block diagram, who can remind me? Abdul Sabit Arif.
Yes, please.
Yeah, what's the most important component in the block diagram that I shared?
The microcontroller.
All right, so let's add the microcontroller. So I'm going to click here, which is the add button. And then this time around, I am going to look for microcontroller. But fortunately, I know the manufacturer, and the manufacturer is called Atmel. Okay. So I'm going to, all right, so I see one here, Atmega 328. Can you see? You may not be able to see it on yours. So let me use one that you can see. So I'll go to Atmel. Can you all see Atmel in your libraries? And then I'll come and select Mega 8-P, this one. Mega 8-P. The reason I'm selecting it is because it has the same footprint as the microcontroller I am using. Okay, so select Mega 8-P. Another thing you can also do is to type in the name over here. You can type in Mega 8-P. And when you type it, it will come over here for you to see. Now, let's look on the right side of it. On the right side of it, you see do you all see this? You see this red box over here. This is the symbol of the microcontroller, and this is the footprint of the microcontroller. So whatever you select, if this is not the footprint, do not select it. Is that clear? Is it clear?
Yes.
Yes.
All right. So the footprint I am using here, this is called the what? The PDIP. PDIP stands for Plastic Dual Inline Package. Plastic Dual Inline Package. So the microcontroller on the Arduino board is what? PDIP 28. The 28 stands for the number of pins that it has. Is that clear?
Yes.
Now, another name for the PDIP 28 is DIL 28. They sometimes call it Dual Inline Package 28. Okay. So I'll press on OK, and then I'll place it in the middle of my PCB. Of my schematic, I still have one at the end of my cursor. So I'll press on what? Escape. All right.
Hello, Nicholas.
Yeah.
Sorry to interrupt you.
No
please, I'm using Proteus, and the only one I'm getting here is Atmega 103.
Search for Mega 328.
Okay, yeah, I think they said is the AVR was replaced by Atmel Atmega 128.
No, no, no,
So I
no.
think
In Proteus, you can easily get 328. I can do another webinar on how to use Proteus to do the same thing, if only you will attend.
sure.
Okay, can I move on? So there are a few things that I need to add. Now, every microcontroller, for it to work, needs three things to work. The first one is a good power supply. The second one is a good clock signal. And the third one is a reset signal. Okay. Almost every microcontroller I know on earth needs those three things: a good clock source, power supply, and then the reset signal before they can start working. So let us add those things to it. Let me first add the power supply. That is just the power supply pins. So I'll click on add, and then in the search box, I'll type VCC. So when I type in VCC, I'll go into a library called Supply One. You may not have these libraries I have here, but you can install them if you know where to get them. But you easily find Supply One. So select Supply One and choose the symbol for VCC, which is this arrow. And then we'll place that somewhere around here. Now, if you want to rotate something, all you have to do is to right click. Okay. So I'll rotate and then place another one over here like that. So I'm placing two VCCs on my board. The next one I'll look for is GND. GND stands for what? Ground. And then I'll once again go to supply one and choose the symbol for what? Ground. And then I'll place it close to this ground and then close to that ground. All right. And then I'll press on escape. Now, the next thing I want to do is to connect these pins to the power supply sources I have provided. So the first, I'll use this one over here for the connection. So this is called the net. Okay. The net is what you use to provide the connections between the various pins of the in the schematic. So I'll click on net and then I'll click on the components leg and then I'll end on this one by double clicking. When I double click, the connection will stop by itself. So I'll click on this one again and then connect this one as well to ground. I'm trying to zoom so you can see very clearly what I am doing. And then I'll click on this one as well, connect this to VCC. And then this one has to go through a resistor before it comes to the reset pin. So what I'll do is I'll click on add path and then I'll go to where I can find resistors. Now, one of the common libraries in Eagle where you can get all discrete components, that is resistors, capacitors, inductors, etc. The name of that library is called RCL. RCL. So I'll scroll all the way down till I see this name here called what? RCL. And then I'll break it down like this. So I'm looking for what? Resistor. So I'll be choosing a resistor with the EU package. So resistor with the what? The EU package. You can also get a resistor with the what? The American symbol. But I'm going to choose the one from what? EU. Because the country I am in now uses British standards. All right, Arif, Abdul Sabit.
Nicholas, please, does the EU and US affect the symbol or the footprint?
They only affect the symbol. The footprint is the same.
Okay, thank you.
Okay, so I'm going to just choose the first one. And when you look at the schematic and you compare with the footprint, they don't look like a resistor. So I'll come down, 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 down. It's beginning to look like a resistor, right? And then the 3D model of it will appear over there. So normally the resistors we have on campus are normally 12 long. Okay, 12 long. So I'm going to choose this package 0207/12. Okay, 0207/12. And then I'll press on OK, and then that becomes my symbol. I'll use the right click operation to rotate it, and then I'll place it over here. So I'll use the net once more to connect between this one and then this one like this. So I have successfully provided a reset signal to my microcontroller. All right. Now the last thing I have to provide for my microcontroller before I can start using it is my clock signal. All right. So I'll click on add
Sorry,
path.
Sanik, I didn't get the resistor, the one we should choose.
Choose 0207/12. That's the common resistor we have in our labs. Abdul Sabit?
I just wanted to ask about the resistor you connected before connecting the power supply. Is that a pull-up resistor?
Yeah, it is a pull-up resistor to the reset pin. So all the time the reset
Okay.
has to be at 5 volts. If it is not, the microcontroller won't work.
Okay.
All right. Can I move on? Any further questions?
Yes, please. And please, can you show me again how you did the next thing to connect the parts to the microcontroller?
Okay. So can you see my screen very clear now? So I click here
Yes, please.
on net. Can you see the net?
Yes.
On the left, and then you come here. When you come
Yes,
here, you
please.
see that there's some zero at the end of the component. Do you see it?
Yeah.
So you click on that, and then you move till you appear at the other zero. Can you see that?
Yes,
Then you
please.
click, okay? And then you come
Okay,
here,
thank you.
there's zero over there. You click,
Yeah.
and then you come down, move to this one, and then you click. Simple.
Yes, please. Thank you.
All right. Can I move on now? Please, if you are genuinely lost, it's very fine. Okay. I'll do another one tomorrow. You can ask me more questions. And you can also watch the videos because I've explained a whole lot in those videos before I started this. So let's now look for the crystal and then provide the crystal to the microcontroller. So I'll go back to add once more. And I honestly don't know where to find the crystal. So all I'll do is to type in what? Crystal. But I know the package I am looking for. And the package I'm looking for is called H49S. It looks something like this. Have you all seen this before? That's the 3D model of it. It's called HC49. So I'll take this one and then I'll bring it here somewhere like this. Now, every crystal that you bring into your schematic, you need to give it something we call load capacitors, 2 load capacitors. Normally, they recommend between 12 picofarad and 22 picofarads. Okay, so we need to bring those 2 capacitors. So once again, I don't know where to find my capacitor, so I'll just type capacitor. And when I select my capacitor, I'll look for RCL because that's where I know I can get my capacitors. And then I'll choose the first one that comes. So I'm looking for a capacitor that looks, I'll share the picture of it with you briefly. But this is the correct package for what I am looking for. It's a fixed capacitor. So I'll take this one, rotate it like this, and then bring the next one here, rotate it like that, and then I'll place them. After that, I'll use the net once more, connect this one to that one, connect this guy to this guy, connect this to this guy, connect this one to this like this, connect this to this. And then the next thing I'll do is I'm coming to use the copy function. I'll click on copy, and then I'll copy one ground, and then I'll come and just paste it onto the end of the load capacitors. Okay. So let me allow you 1 minute to finish what I have done. Now, this session will be lasting today and tomorrow. So if we don't finish today, we can finish tomorrow. So if you are done with where I've reached, you can just send me a prompt in the chat box so that I know that you are done.
Sorry, Sonic, I can't find the 49S, the H49S.
Look for a library named Crystal.
Yes, I'm there, and I found 49G.
Does it look like the
Another
blueprint
one.
I used?
No, I think somehow.
If it looks like it, you can use it. So
Okay.
when you go down, you see a library called. Okay, do you know? Let me show you where to find it. Okay. Look for a library named Special. Special. Yeah, a library named Special. I'm on it now. So take this one. Search for XTAL/S.
I'm there.
Can you see it? So you can use this one.
Okay.
Okay. Oh, I want some feedback from you guys. I want to see those who are missing and those who are not. Who has been able to do it to where we've reached? Should I repeat it again?
The last few steps, please. Me, I'm lost from the when you added the crystal and then the capacitor.
The load capacity.
I didn't get.
Okay.
Yes, please.
Okay. So I'll do it, but I'll do it fast. So I'm using delete to delete what and what and what I've added. Okay.
Okay.
Okay. Are you okay now?
Yes, please.
So I'll click on add part, and then I'll look for a folder called special.
Okay.
And I'll click on special. You can find 7 segment displays in the special folder as well. Okay. There are a lot of useful things in that special folder. Okay. You can find transformer there, and then you can find a crystal. So you can look for XTAL/S or look for the previous one I choose. And then when you bring it here, you can rotate it and you press on escape. After that, you can go to RCL. RCL, as I said earlier, is the library path for all the discrete components in Eagle. So I'll go to RCL and then capacitor EU. This is the right footprint I'm looking for a fixed capacitor. So I'll take it, place it here, and then place it here like this. And then I'll use net to connect between this leg and that leg. Understood? Use this one, connect between this and that. Use this, connect between this and that as well. And now I need to connect the legs of the microcontroller to the crystal. So I'll click on this one, take this leg as well, connect to that one. And then the last thing I'll do is to connect all of this to ground. Let me use a different approach. I'll use the move icon, move the ground pin back a little, move this one also back a little, move this one back a little, and then I'll use the net to connect between here and this net. It will ask me, do you want to connect this, and I'll say yes. And then that is all for my schematic. Anybody lost again? Okay, so I will upload the video from this session into YouTube quickly after the presentation. So you can watch it back from YouTube after the presentation. All right, can we move on now? All right, so somebody should suggest what we should add. Ohiniwa, in at the block diagram, which part of the circuit should we implement now? Ohiniwa, are you there?
Yes, please. Please, I don't know.
Pardon me.
I'm looking at the block diagram. Okay.
You can't see the block diagram.
Please, I'm not sure.
Okay, so in the block diagram, there were 2 push buttons. Okay, let's add those 2 push buttons. So you go back to add, and then when you go to add, there is another library part called switch. Switch. They are right here, around here. And then we have switch with different manufacturers. So the type of push button I'm looking for, I can find it in what? Switch Omron. Do you identify this footprint? These switches were inside the box we sent you for those taking embedded systems. Okay, so I'll choose 2 of this. So I'll rotate it, and then I'll place one here, and then I'll place the other over here as well. Okay. The next thing I'll do is I'll connect the legs of the switches together, and then I'll connect them to ground. So I'll take this copy, look for the ground symbol like this, and I'll rotate the ground symbol, and then I'll place the ground symbol on this line. Now, the next thing I want to do is to just make an extension of one of these pins. So I'll extend it somewhere like this, and then I'll take this one as well, extend it by double clicking when I get to where I want to stop at. Okay. And then in the schematic that I shared on YouTube, who remembers the pin that I connected the push buttons to? Can anybody refer for me? Okay, so I connected the switches to port D6 and then port D7. Port D6 and then port D7. So I'll extend those pins as well. I'll extend this one like this, and then I will extend this one as well like that. Now, what I'm coming to use is called labels. Okay, so I'll come here to name, and when I come to name, I'll click on this cable or this net, and then I'll call it switch 1. And then when the switch is at the end of the cursor, I'll come to this side, and then I'll click on this XREF on like this. And then I'll rotate it like this, and then I'll place it at the end of the net. That way I've labeled the switch. So I'll click on the name once more, and then I'll call this one switch 2. So the same settings will be used, and I'll have my switch 2 over here. I will now come here, and then I'll name this one as well switch 1. It will ask me that funny question. I'll say yes, and then I'll rotate this one. But this one appears to be very big, so I'll scale it down a little. And then I'll name the second one switch 2. Okay, so who can tell me what I just did? Anybody? If I call this one switch 1 and I call this one switch 1, do I need to provide any physical connection between this one and this one? All right, so Felicity says no, and she's right. So I've used the name command to name this wire to be switch 1, and then I've connected it to this wire, and I've labeled this one switch 2, and I've connected it to this one in software. Okay, so I don't have to draw a cable from this point to that point. Is that clear? So we are done adding the 2 switches to our project. Okay. Please, any questions? Okay, so what I will do is I'll be ending this session in the next 4 minutes. We can continue drawing it tomorrow, and then I'm sure we'll finish the printed circuit board tomorrow. I don't want to take too much of your time. So please take the next 3 minutes, try and finish what you have done, and then take a screenshot and share it with all of us to see. I'll be watching the screenshots that you share. You can share it on WhatsApp or you can share it on Zoom, whichever one is easier for you. You can share it in your class group and I'll be able to see it.
Please, I just got lost. The switch, what was the switch model that you chose?
You can find it under switch, and the folder is called Omron. Switch-Omron. Abina Konedu.
Okay.
Nicholas, please can you go over the labeling part again.
Okay, so I should go over the labeling part. All right.
Yes, please.
Okay. So I'll delete what I've done already, and then I'll just do them once more. So this is how it was, right? So I'm coming to net. When I come to net, I'll take one of these, connect some short wire to it, double click. When I double click, the wire stops. Take the second one, connect another wire to it, double click, and then the wire stops. And then those switches were connected to PD6 and then PD7. So I'll come here, connect another short wire like this, connect another one like that. So I want to use the name feature to name this one as something. And then because I've named it something, it will be interconnected to each other. So I'll come here to name by clicking on this icon with R2 on it. When I click on it, I'll click on this and you see the N followed by the $sign, followed by some number. I will erase that and then I'll call it switch 1. And then I'll press on enter. When I press on enter, you see that switch 1 will appear at the end of what? My cursor. So I'll rotate it nicely and then I'll place it over there. Then I'll activate the name command again. Click on this one, call this one switch 2. And then now the settings are still there. So I'll just place it near to the cable connected to the push button. Then I'll come down here. I'll click on the name command again, call this one switch 1. It will ask me, do I want to connect net 6 to switch 1? And I'll say yes. When I say yes, then switch 1 will appear at the end of it. And then I'll rotate it nicely and place it like that. And then my name command is still active. I'll press on the last net, and then I'll call it switch 2. I'll say yes, and then I'll place it over there once more. So very, very simple. We have about 1 minute more.
Thank you.
All right. So I'll be hoping to see you guys in the next session tomorrow. And I will be praying that we'll finish the whole PCB tomorrow. So when you are coming,